So far, we've focused on injecting services into classes and page models via constructor injection. In this demo, we'll focus on injection of dependencies into ASP.NET Core controllers. Besides constructor injection, I'll demonstrate that we can also inject services into action methods via action injection. The admin area of the tennis booking application is created using a classic model view controller pattern. Let's open the courts controller and look at the options for dependency injection. Currently, the controller accepts free services via constructor injection. This works in just the same way as the constructor injection that we've used elsewhere. One of the injected services is an iCourt maintenance service, and that's used by the upcoming maintenance action method. Now, if I scroll down past the other action methods, we can see that this service is not required anywhere else in this controller. It's important to understand that ASP.NET Core activates a new controller instance per request. The iCourt maintenance service needs to be registered as a scope service with the dependency injection container. Therefore, every time a new request comes in, which this controller handles, the controller will be activated by the framework, and a new instance of the iCourt maintenance service will be instantiated. This results in additional allocations of the core maintenance service object, which will later need to be reclaimed during garbage collection. Because this service is only needed by one action in this controller, it's slightly wasteful for requests that are routed to any of the other action methods. One way to address the problem is to use action injection for the iCourt maintenance service. To do this, we'll add a parameter for the upcoming maintenance method. We'll mark this parameter with the FromServices attribute. This attribute identifies that this parameter should be resolved from the dependency injection container. This parameter is of type iCourt maintenance service and we'll name it appropriately. We can update the action method to use the method parameter rather than the field. Since we don't use this service elsewhere, we can remove it from the constructor and therefore remove the backing field. Now when a request routes to this controller, only the iCourt booking service and the IUTC time service need to be resolved from the container. Only in cases where the upcoming maintenance method is the destination for the request will the iCourt maintenance service be resolved from the container, causing a new instance to be created. We need to register the iCourt maintenance service inside the program class because we haven't done so yet. And with these changes complete, I'll press F5 to begin debugging. Once the site loads, we can access the administrator area and visit the admin pages. We can view the upcoming court maintenance schedule, proving that the service has been injected correctly. Choosing between constructor injection and action injection depends on how widely used a dependency is within a controller. Generally, constructor injection is preferred and most commonly used in controllers. Action injection is one solution to the example that we've just reviewed. Often, this problem is indicative of a controller that maybe has too many responsibilities. When you find yourself with controllers that have many dependencies, especially those that are used by only certain action methods, it may be time to consider reviewing if the actions should be separated into more focused controllers. We could have created a controller with specific responsibility for court maintenance in this example. ASP.NET Core 6 ships with an alternative way to build simple HTTP APIs requiring less code and ceremony known as minimal APIs. In this demo, we'll create a basic weather API using the minimal API technique, learning how to inject dependencies where they're required. Within the solution, we have one project that we've not yet explored. Before we do anything else, we'll set this Weather Service API project as the startup project for the solution. This project was created using the ASP.NET Core empty template. It includes a single program.cs file that we'll open. Thanks to recent C# features such as top-level statements and global usings, this file contains 6 lines of code that define a complete and working API. The template maps a single GET endpoint for the root path that returns a plain text string. We'll add an endpoint to this API to return weather forecast data to demonstrate how to inject dependencies into these minimal API endpoints. First, we'll add a project reference to the tennisbookings.shared project. Next, we'll need to register our random weather forecaster as a singleton service. Registering services in Minimal APIs occurs in the same way as we've used in the tennis booking web application, by accessing the iService provider on the builder via the services property. We can use the add singleton method to register this service with the container. After the web application is built from the web application builder, we can map routes and handlers for any endpoints we wish to create. We won't create a new route. Instead, we can update the pattern to /weather/city to define a path our endpoint will handle. Any GET request to /weather, followed by / and then a city name, will be routed to this handler. Curly braces around the city define it as a route parameter, provided as a path part in the URL. The functionality for the endpoint is provided by a delegate representing a handler for the request. We can use a lambda to define the logic of this endpoint. Our handler requires two parameters to function. First, we'll accept a string parameter named city, which will be bound from the route parameter and give us access to the city value from the path. The second parameter will accept an iWeather forecaster service. Minimal APIs have built-in support for injecting dependencies, and we're not required to attribute this parameter in any particular way for it to function. We'll be calling asynchronous methods inside our handler, so we must mark it with the async keyword. To provide the behavior for our endpoint, we can use a block body to perform our workload. First, we'll use the injected iWeather forecaster dependency to request the current forecast for the provided city. We'll return the weather from the forecast as the body of the HTML response. By default, ASP.NET Core Minimal APIs return JSON serialized content when the return type of the handler is a complex object. We can press F5 to begin debugging the application, and once the browser launches, we can navigate to the expected path of /weather/city name. The handler gets invoked and the JSON serialized weather data is returned. Minimal APIs are designed to take as much ceremony out of creating lightweight APIs as possible. As we've seen in this demo, registering services is unchanged from the rest of ASP.NET Core 6. Resolving services is as simple as including dependencies as parameters of the handler delegate. We're done with this sample Minimal API project, so if you're following along, don't forget to set your startup project back to the tennis bookings application before proceeding. Another common location to inject services is into ASP.NET Core middleware components. In this demo, we'll explore our options for injecting services into middleware. We'll cover the different behavior of each option and learn why it's essential to make the correct choice. While middleware components support constructor injection, the activation of middleware differs from the other framework components, such as controllers. This has a crucial impact on the injection of dependencies. We'll add a middleware component to the application to support tracking the date and time of the last request for a known user. To begin, we'll add a new folder called middleware. Inside this folder, we can choose to add a new class, which we'll name last request middleware. Rather than watch me type everything, I'll paste in the code for this middleware. All conventional middleware should accept a next request delegate as a parameter in the constructor, just as this middleware does. In addition, we can provide extra services that will be injected via dependency injection. Will depend on the IUTC time service and the user manager. The user manager is a service registered and included as part of ASP.NET Core Identity, which provides the authentication functionality for registering and logging in users. The invoke async method includes logic to identify the logged in user if we have one for the current request. The user object is updated so that the last request UTC property is set with the current date and time provided by the IUTC time service before saving the updated user back to the database. I'll add a breakpoint here that we can use in a moment. After creating a middleware class, we must register it into the application request pipeline. At the bottom of the program file, we can configure that pipeline. We'll add our middleware after the calls to use authentication and use authorization. We need to add a using directive for our middleware namespace. At this point in the request pipeline, we'll have the claims principal for the user attached to the HTTP context if the request comes from a logged in user. Let's run the application and see what happens. An invalid operation exception is thrown almost immediately. Focus on the error message and you'll see that the exception is familiar. When we discussed scope validation in the module called the Microsoft Dependency Injection Container, we saw that such an error suggests that we have incorrectly captured a scope service inside a singleton. Let's stop debugging and jump back to the code to understand what caused this exception. Middleware components are constructed once during the application's lifetime, with any constructor dependencies being resolved from the root container. This means that the middleware components are singletons within the application, and any dependencies injected via the constructor are therefore captured for the application's lifetime. This behavior differs compared to controllers, for example, where we saw that a new controller instance is activated for every request. When using constructor injection with middleware, we shouldn't inject short-lived scoped or transient services via the constructor. Here, the user manager dependency is a scope service within the application. So how should we solve this? Middleware supports a second point of injection via parameters of the invoke or invoke async methods. This method is invoked once per request. Its parameters are resolved from the container via the scope of the current request. To fix this application, we'll move the user manager parameter into the invoke async method. We can remove the private field and its assignment as well. Finally, we'll modify the code in the invoke async method to use the method parameter. To recap, all we've done is move the user manager parameter from the constructor onto the invoke async method. We then access the methods of the user manager from the method parameter. Let's run the application to see if this has resolved things. This time, our application loads correctly, without exception, and behaves as expected. The breakpoint in our middleware is hit as the logged-in user is being updated. When injecting dependencies into middleware, choosing the correct point of injection is vital to fit your requirements. Conventional middleware constructors run once when the middleware is added to the application and the request pipeline is built. Singleton services can be safely injected into middleware constructors, but all other lifetimes should be avoided. Scoped and transient services may end up being captured for longer than their intended lifetime if resolved via a middleware constructor. The invoke and invoke async methods are called once per request, with the services activated and resolved from the request scope. Therefore, it's safe to inject services of any lifetime into these methods.